with that, I'll start with introducing Bastian Schaefer. He is a maverick. He is a kite surfer. He is from the south of Germany. And welcome, Bastian.
That was too quick. So, the idea of flying is as old as people are looking at birds. So I would say it's as old as people are living on this planet. To meet the future passenger expectations and to rethink how we are flying today, we're sitting together with some innovators and designers and wanted to create a completely new passenger experience. But before we look too much into the future, it's time to go back a little bit. There are a lot of people who doubted that flying is possible somehow. So a statement given by Lord Kelvin basically didn't believe in the fact that we will fly in helicopters and airplanes. So balloons were very common at that time. They are lighter than air. But something which is heavier than air, like a commercial airplane, for instance, that was not thinkable at that time. Just some years later, the world saw this picture from the Kitty Hawk. It's basically a completely new invention, and two things came together. The combustion engine and a certain understanding about aerodynamics. But also here we find a very hard statement, so no flying machine will ever fly from New York to Paris, which was given in 1908. Just a couple of years later, people were dreaming about a kind of large aircraft which offers the comfort which you know from your living room. So, and it says here, it crosses the Atlantic Ocean in just 1.5 days. So now, think about sitting in an economy class seat for 1.5 days. So this is very painful. Today, it's not a question if we can go from New York to Paris, but the question is more, can our customer sit in his jacuzzi or in his swimming pool inside his airplane and listen to some classical music? Well, actually, today it's the choice of our customer. Today, 8 million people per day are using a commercial aircraft. So we have more than 18,000 commercial flights per day. And if you believe you're the only one besides some others in your airplane crossing the Atlantic Ocean, I can tell you there are a lot of people behind you going with 700 miles an hour crossing the Atlantic Ocean right behind you. It's a kind of swarm intelligence we have here, I would say. So when we are thinking about a new kind of aircraft concept, we ask ourselves, how does the world in 2050 look like? So we see that we have more than 9 billion people living on this earth, and a lot of them will make money and spend this for traveling. So there will be an increased demand for traveling, and the expectations on commercial flights will be higher than today. So we wanted to start with a passenger and design the aircraft around him. So what are the future passengers? So before we come to this question, we have to think about what can we do in terms of passenger needs and technology. So we call this consumer-centric approach, and we started with a passenger. So let's meet the future passengers. So women will play a major role how commercial airplanes are designed in the future. More than 70% of women will acquire for higher education, which basically means that from 10 students, 7 students will be female in the future. And as a matter of fact, we will see more female business travelers. In some areas of this world, the population is getting older and older. We have this trend very strong in Japan, but also in Germany and Italy. So we have a kind of graying society here. And a lot of these people save their money, and when they are getting retired, they can spend this for traveling around the world and enjoy their life. So also here we need to meet the expectations and the demand for these kind of people. And this is a very large trend, overweight and obesity. To give you one number, the World Health Organization predicted that in 2050, I think, 80% of all US Americans will deal with obesity. We have, okay, futurists like to deal with these large numbers, and so I don't want to blame the USA here. So we have, of course, this trend in Germany and in the Western civilization in general. So, but maybe it's time to look down on yourself and to do some more sports activities. And so these are basically 3 future passengers which we took in our focus, and we wanted to combine this with technology. So what we see today, what we learned today is that data is the key of success. Data will help us to create new kind of materials, and we use these new kind of materials to do new kind of structures. We have seen a lot of examples today. So one of the things which is really amazing to us at Airbus is how nature is building stuff. So we have this very small building blocks called DNA, and we find all the information to build a large skeleton out of it. So we call this top-down and bottom-up approach. Bottom-up because all the information to build the skeleton is stored in the DNA, and top-down because you can train your muscles, and then you are getting stronger. So you can adapt your body on different environmental conditions, and this is a very nice function which nature delivers for free. So our building blocks could be carbon nanotubes in the future, which are as big as DNA. And of course, the vision is clear to use this material and build a large rivetless skeleton out of it. So we managed today to print carbon nanotubes inside a 3D printer. We do this with the University of Exeter in England. We have trillions of them, and we call them aligned woods of carbon nanotubes. And at the next level, we can use these woods and make a kind of morphology optimization, which basically makes the material transmitting energy and acting as a sensor. Then we take state-of-the-art topology optimization, for instance, and build larger and larger components in the future. That's basically the idea behind it. It works in a laboratory, but you never know. In the future, we might have the chance to use a large 3D printer and use this material to print structures out of it. So our vision about the concept cabin combines a different kind of technologies. 3D printing is just one of the ideas which is behind it, and I just want to show you a short animation of what you can expect from the future. So we have wide central doors, and you are welcoming inside the boarding area. You don't need a boarding ticket anymore. You're recognized by your DNA or by your fingertip or whatever. The technology is available. Luggage is very annoying. Hand luggage, so we want you to get rid of your hand luggage right in the entrance area and make the boarding process more convenient. The reconfiguration of the cabin is very essential for our customers, the airliners. So if there are some empty seats, we can wrap the empty seats together and offer more leg room. We have a lot of morphing materials here, which addresses basically the needs of passengers who are a little bit larger. So during the flight, the entrance area turns into a kind of Disneyland, I would say. So we put digital wallpapers everywhere, very thin kind of displays, which we could put on the floor, on the walls, on the ceiling, wherever. And by offering this technology, we can easily reconfigure this area. So you can play digitally golf. Don't laugh, we had a real putter challenge inside an A320 once upon a time. Well, this is my favorite scenario, a bar scenario, which offers a kind of advanced outside view of the airplane, so a kind of sky lounge. I guess this is very cozy. So, but the real highlight comes in the front of the airplane, which we call the vitalizing zone. So we don't have the first class and business class and economy class anymore. We want to offer a very exciting view out of the airplane. So if you ask the people, some of them are getting afraid about this vision, some of them feel excited about it. So the entire environment is very responsive to the passenger. So for instance, when you're getting blinded by the sun, you can make a kind of gesture, and the cabin membrane, which covers this bionic structure, is turning opaque in some areas. We don't have a cockpit anymore. When you look at the comments at YouTube on this video, for example, you will see that there are some pilots who are really getting mad with us. So there are two answers on this. The first answer could be the cockpit is somewhere else in the airplane, so in the cargo area, for example. The second answer is, in the future, we maybe do not need pilots anymore because we fly highly automatically. And well, we like to bring the passenger back where he is actually. So I guess an airplane is the best place to watch the stars at night, and so we really hope that we are getting the right materials and yeah, basically also the right method behind it in terms of optimization to help us to make this vision come true. So in the next step, I want to give some details. So this vision is quite large, but we are starting small. The first thing I want to show you is tooling on demand. So I would call this high-tech, low-cost prothesis. So you don't need necessarily to use to lose your leg if you want to wear a kind of prothesis. If you're a blue collar at Airbus, you will be able to have a kind of prothesis which you can stick on your finger and which helps you to disassemble or assemble stuff inside the airplane. And this works quite well. It's cheap and you're getting the right tool which you need. It doesn't need to be necessarily always a screwdriver. This is our first spare part which we have been producing. We call this belt mold. It's designed for an Airbus A300. This airplane is 30 years old. The supplier went bankrupt, and new tooling for this part, because the old one was destroyed, the old tooling, would cost more than 40,000 bucks. So we said we like to print this kind of belt mold, and we used the FDM procedure for it and applied a little bit of post-production, and we easily can create spare parts from it. Our vision is clearly to reduce the stock holding of spare parts down to 30% in the future. And each year we are getting more and more parts to achieve this. So digital stock holding is a big issue here in terms of 3D printing. This part concerned me a little bit because it's a part of the fueling system of the airplane, a fuel connector. It was made by 14 parts, and just by switching the manufacturing technology to additive manufacturing, we were able to just produce this part in one shot. And it worked quite well. We produced this inside an X1000R from Concept Laser, which is basically the biggest available powdered bed printer today. And it was quite successful. So the costs are competitive in terms of when you compare this to casting, for example. This is also a nice part. So this is a vertical tail of the airplane. You can see it at the left picture. And what we are doing here is we use additive manufacturing to create multifunctional parts. So this is not only a leading edge of a wing, if you will. We have the possibility here to make some micropores into the leading edge of this part, and you can see that in the back there is a connector to stick a kind of ducting to it, and then we can suck out the air of this double-walled leading edge wing. So, which improves the aerodynamic performance of our wings. This also works quite well. So, yeah, This is basically at the moment our highlight. This is a bionic bracket. We are absolutely proud about this bracket. At the same time, it's the biggest disappointment for our structural engineers, and I want to explain why. So first of all, we are very proud because we are winning a lot of awards with this technology. So we reprint metal here and bring this into commercial airplanes. We have been under the finalists of the Innovation Award of the German economy last year. So this bracket was designed to hold 1.7 tons. We added a German Angstfaktor to it and designed it to resist 3.4 tons. So then we put it onto a testing device, onto a machine which can apply forces of 10 tons to it. I can show you a picture here. This is the installation, and it was really surprising. So at 6 tons, the screws which attached the bracket to the panel there were flying away. At 10 tons, the machine crashed down, but the bracket was still in one piece. Then we put it onto a bigger machine, which can apply forces of 100 tons, and at 12 to 13 tons, this part was breaking. But it just had to hold 3.4 tons. So it's oversized by factor 4, and that's why it's a big disappointment for our structural engineers, even if this part is 50% lighter. So the question is, how do we have to design this to meet these 3.4 tons? We are doing a lot of stuff in terms of scanning. So what you can see here is a water lily, the Victoria water lily. It's basically the biggest water plant which you can see in a botanic garden. So we went there and we wanted to scan this to understand a little bit the procedure and the design of it. So it's time to learn German. Listen and repeat. Die Königin der Seerosen, the queen of water lilies. It worked quite well. It was an amazing project. So, and also a completely different approach how to create and understand structures in the end of the day. So here you can see one of my colleagues scanning the water lily. They are very strong. So maybe you can see some pictures somewhere in the internet where children are sitting on this water lily. If you want to do this with your child as well, make sure it can swim. So it's very, very stable. And what we are doing with this, we integrate this kind of design procedure into spoilers. So we call this a biospoiler project. And this is basically the result, a completely different kind of structure inside a spoiler of an airplane. The spoiler is really important. If you want your airplane to stop in the end of the runway, you need this part. And we will print this on this kind of printer. It's a project with Aerosud in South Africa. I have to translate the numbers to you. Unfortunately, you're not using the metric system. So the build chamber is more or less 7 feet times 2 feet times 2 feet. So it's quite large. It's a very, very fast printer, and we will print this spoiler this year on this machine. We use titanium here. And this is very exciting for us to see the printer size is growing. The printers are getting faster and faster and make the production of those parts more easily. So I'd like to come to an end by giving another example of how we are using scanning. So at the right-hand side, you can see some micro CT pictures, and the results we are getting from this were really astonishing for us. And when you are printing a part, you always have a certain kind of porosity in this part. When you apply micro CT to it, you are scanning also these kind of holes inside the part, and later on, when you print this part again, all these holes are printed as well. So there is a kind of danger in violating IPs, for instance. It's not a matter. It's not a big deal in the aviation industry, because every part which we deliver to an airplane comes with a ton of documentation. So it's very hard to to certify copied parts. But at least we have to take care about this, about copying things and violating IP and all that stuff. So we like to encourage our engineers to think big in a certain way. So all these samples which I've been showing have been created in the last 2 years. And it's quite amazing for us to see how the community is growing. And let me close with a statement of Jason Silver. He once upon a time said, if we can imagine it, why not making so? So we are encouraging our engineers and also want to encourage you, go into this technology and help us to print an airplane in the future. And I believe this will happen. Thank you.